This is the STD-502 and TB-STD502 demonstration video. The STD-502 finds its uses mainly in remote control, but other uses can include telemetry and monitoring. So, what is special about the STD-502? It's in the 2.4 GHz band and uses direct sequence spread spectrum, all done by an ASIC designed by Circuit Design. The key process is that the DSS multiplies the modulated signal by a spreading code, which makes it spread over a wider bandwidth, which hides the signal in the noise. The spreaded code is then transmitted as it is to the receiver. When the signal reaches the receiver, a despreading code is applied and the signal is compressed back to its original bandwidth. The signal is demodulated and the original data is recovered. To set up the STD-502 module, we use UART serial commands as shown in the next example. For example, to set up the bit rate, we send *B19 into the RxD pin. Once the command is sent to the module responds by sending an acknowledgement back to the source. A list of all other commands is shown here, for example country code, setting the channel, etc. To send data across the air, we insert data into the data in terminal of the STD-502, and because the transparent interface is used, the user can use his own protocol. The range achieved is about 300 meters line of sight. The STD-502 features a diversity function using two antennas, which allows the STD-502 to detect which signal is stronger at which antenna and select the appropriate signal. Circuit Design also feature a special tool which allows you to plan your channels out in order to avoid interference as much as possible due to third order intermodulation interference. This is the end of the STD-502 module presentation. Next is the test board STD-502. Circuit Design also sell an evaluation board for the module as shown here. The white area on this board is where you insert the module. Once the module is inserted onto the board, you select the mode of operation using these dip switches. Use these rotary switches to set the frequency and channel. Use these rotary switches to set the ID of the signal. And finally, these switches are used to transmit the data. Now we will explain more about each of the modes. For the one-way transmission, you just push the switch on the transmitter board and the corresponding LED will light up on the receiver board. For the two-way transmission, it is exactly the same but this time an acknowledgement is sent back to the transmitter board, and the LED on the transmitter board will light up. The packet test involves sending a packet from the transmitter to the receiver board, set the dip switch for packet mode, and set the packet length and number of packets using the rotary switch. Now push the button to initiate packet transmission. As the packet is transmitted, the LEDs on both boards will flash. When the packet has finished transmitting, the receiver board LEDs will light according to the number of packet errors it has detected. To use the two-way packet test transmission, set the dip switch as follows and the packet length and number of packets. As before, the LEDs will flash, but this time an acknowledgement comes back from the receiver board back to the transmitter. Finally, the transmitter board LEDs will flash up the number of errors in the packet. The user access mode allows you to access the STD-502 terminals directly. Here, if you set the dip switch, you can turn the frame coincidence detection on or off. As shown here, the pins are direct access. The pins are accessed directly from the side of the board as shown here. For example, the pins and also the UART. The STD-502 meets the regulations for European ETSI, the US FCC and the Japanese ARIB standards. This is the end of the video. If there are any questions, please contact Circuit Design on the website.